Jonathan Bohbot. I'm a doctor in biology in the Department of Entomology, which is insect science. And that's it. When I started working on mosquitoes, it was about to find attractants or repellents, so attracting them to kill them or try to protect ourselves against their approach. But surprisingly, as we studied their sense of smell from a very basic research point of view, we discovered that they were smelling things that are very important to us, things that we put in perfume, things that we put as additives to food, or additives to cigarettes, or we put in ice cream, compounds that we use every day. And they have these smell receptors, this little molecule that can detect these compounds of enormous importance to us. And the surprise was this: what if we could literally steal from the mosquito these smell receptors and build and engineer an artificial nose, a biosensor of some sort, something portable, something quick to smell. And that biosensor would need to be very fast, very sensitive, and very selective. And it just so happens that mosquitoes have these smell receptors that we can take from them. And that was a big surprise because it took us in a very different directions in terms of research. We do really Frankenstein type of experiments in the lab. Okay, we look at them through the microscope. We do some behavioral experiments. That's classic. But we do something really funky, if I may say. We take these smell receptors as an RNA molecule, as a gene, if you will, and we inject that in frog eggs. And that's really interesting because these frog eggs, so they belong to these big animals, right, are big. They're very big cells. They're cells that you can see with the naked eye. They're about 1 millimeter diameter. And what we do, we inject inside these eggs the DNA of these smell receptors. And then we can probe these eggs. We can really interrogate these eggs and say, hey, eggs, what do you smell now that you have these smell receptors on your surface? And we can do all kinds of pharmacological experiments trying to find out what kind of smell tickle these receptors, or what kind of drug prevent their function. And in this way, we can discover how sensitive and how selective and how useful these mosquito receptors can be to us. Biosensors can detect these interesting compounds, such as compounds that you detect in wine, compounds that you detect in the breath of people who have certain diseases. We can detect compounds that are indicative of food that is being spoiled by bacteria or fungi. So this is where we see that a major section of our research will go to. And that's very exciting because this is really in the leading edge of research. And for that, I need to collaborate with other researchers, nanotechnologists, bioelectronic engineers. And it's fascinating because now I get to interact with fields of research I have no clue about, to build something completely new that nobody has ever done before. So we see that if we're successful, and until now we are starting this research and it's going in the right direction, it seems that we will be able to build this new biosensor based on mosquito smell receptors. But later we can expand to other receptors from other insects. We can take this receptor from this insect because it detects this compound that we like, etc. So that's one of the major future, what do you say, research path that we're exploring actively.